Hello, I am Nibirh Jawad on behalf of Group 7, giving a brief demo about our project. Our project was to build a user controller game using an FPGA. We used a CRT monitor to display our game and used an ALTERA UP2 kit to program our game, and we used Quartus as our compiler to do this job. And we also used the ByteBlaster 2 to interface our FPGA board with the PC using a parallel port. This is our FPGA board, the UP2 kit, and here we are using the Flex 10K FPGA. We are using the 2 push buttons as well as the DIP switches on the board. Now if we move on to our game, we can see that we have 3 planes, our opponents, which are trying to attack us, and we are in this plane over here, and we will try to stop them from coming to our base. So let's start the game. Now we can see that the movement is free. We can shoot, and as you can see, the shooting only works if I only hit the plane at a special point. If I hit anywhere else on the plane, it does not vanish. So we are playing, and we can see that the score is also increasing on the FPGA board. We have a score here on a 7-segment display, and the score is increasing as I'm hitting the planes. And also, if I don't hit them, if I'm unable to hit them, then as the planes come to my base, my score will be subtracted. I missed, and my score was subtracted by 3. So this will continue until my score has reached below 0. As soon as it reaches below 0, the screen becomes red and you have lost the game. So that's all for our game. Let's move on to our code now. You can see the code is quite big, but I will try to explain as much as I can. We have a lot of input, outputs, wires, registers here. I won't go through all of them. But basically what we need to see is that here we have a clock division, so that my clock, which was originally around 20 megahertz, is a bit slower now, because at 20 megahertz we won't be able to see anything on the screen. Then we move on to my VGA controller, which gives the output signal through the VGA port to my VGA monitor. We have here a failed test to use the keyboard, which was quite sad. We thought we could use the keyboard for input, but it didn't work out. If we move on, the main code starts from here and extends for about 200 lines. And in this part, we have our shooting code, our hitting logic, we have our misfiring logic, we also have our opponent moving logic, the independent movement of our opponents, we have the collision of the opponents with our base, we have the movement of our plane, we have speed increase, which we did not show, but the speed increases at an interval of 200 clock cycles. We also have a reset button, so that when the game ends, we can reset it. We have a code for showing the score on a 7-segment display, and we also have an end game condition, which depends on the score, which if it goes across 10 or below 15, the game will end. Here we have the printing logic, and here we are printing the screen pixel by pixel. First we go along the x-axis, which is the x count. We increase it by 1, and if it encounters either our firing, shooting, or our opponent, or even my plane, as in here, then it will print different colors. But otherwise, it will only print black. In case of endgame, if I am not dead, then the whole screen will become white, which has meant that I have won. And if I am dead, then it will become red. And basically that is all. The rest here is some registers and combinational logic, which I will not go through here. And that ends our code. And that is the final output of our game. I hope you will have fun playing this game, although it is not that much sophisticated, but we have tried our best. Thank you. Goodbye.